This is the second video for 9.2. You might be asking yourself, why are we talking about parabolas again when we already did a whole chapter on parabolas? Well, actually it was on quadratics. That's quadratic functions, but also quadratic equations and solving them, the quadratic formula, things like that. That was chapter 7. Well, the reason is because in that section we did parabolas with a horizontal directrix. That means their axis of symmetry is vertical. And in this section, we're going to do parabolas where the directrix is vertical, and that makes the axis of symmetry horizontal. And we won't talk anymore about the directrix. But we will talk about the axis of symmetry. So they're like the parabolas you saw before, but they're sideways. Oops. Okay, so this is parabolas with a horizontal axis of symmetry. And that's what the rest of this section is about, because we already did the vertical ones. So parabolas with a horizontal axis of symmetry have equations of the form x equals ay squared plus by plus c, where a is not equal to 0. This probably looks very familiar. The vertical parabolas, the parabolas with the vertical axis of symmetry, look very similar, except it's y equals ax squared plus bx plus c. So all we've done is exchange the x and the y from the ones we did before. We just switched the x and y. And if you remember back when we did inverses of relations, if you switch the x and y, you're finding the inverse relation. Now I say relation because this equation, x equals ay squared plus by plus c, does not describe a function. X is not, we would say in mathematics, x is not a function of y. So if we solve for x and think of y as the input, that's not a function. Okay? I'm sorry. We're still thinking of the x as the input and the y as the output, but it's not a function anymore. X is a function of y. It's what I meant to say is y is not a function of x. If I solve for y, I would get y equals, and I'd get something with a plus or minus in it, which we know is not usually going to give us a function. Actually, it's never going to give us a function, unless it's plus or minus 0 always. So that's all we've done, is just switch the roles of x and y, and that makes your parabola have a horizontal axis of symmetry. So that's the inverse relation. They're inverses of each other, right? They're inverse relations of each other. So if we look at the graph that we know, the y equals ax squared plus bx plus c, we would, to find the graph of x equals a y squared plus by plus c, we just reflect the first one, the one that we're familiar with already, in the line y equals x, that diagonal line, right? So I just drew an example for you. This is the graph of that function. Okay, it's supposed to look like a parabola. And that's its axis of symmetry, x equals 2. So the axis of symmetry for the inverse will be y equals 2. Because you're switching x and y, if you remember. And the formula, you just switch the x and y. And the vertex, you just switch the x and y coordinate. It's that simple. Okay, so it looks a little bit complicated in the picture, maybe. So I'm reflecting across the line y equals x, and I get this. Okay? And that's the one we're interested in now. Notice it looks like a sideways parabola. Notice that the first one opens up. That's because the leading coefficient is 1, which is positive. And the new one, x equals y squared minus 4y plus 5, opens to the right. what it's doing is it's opening towards the positive x-axis, whereas the original one, y equals x squared minus 4x plus 5, opens towards the positive y-axis. So positive y-axis, positive x becomes the positive x-axis, if you remember that. That's why it flips over the line y equals x. That's one of the reasons. Okay, so that's our axis of symmetry. So we have a horizontal axis of symmetry. The red axis is at y equals 2. That's for the green parabola, the one opening to the right towards the positive x-axis. Okay, so they're just inverses of the ones that we did before.